Good morning to all of you. Myself, Pandiraj, Assistant Professor of EC Department, Kalsaling University. So today we are going to discuss the formation of PN junction diode and the formation of positive ion and negative ion and depletion treaty. First of all, as we know that how the N-type semiconductor and P-type semiconductors are formed. That is, when you are adding impurities, that is pentavalent impurities to the introduced semiconductor, the N-type semiconductor is formed, and when we are adding trivalent impurities to the P-type semiconductor, P-type semiconductor is formed. And also we know that the majority carriers in N-type semiconductors are electrons, and the majority carriers of P-type semiconductors are holes. You can look at the picture. So there is an N-type semiconductor and there is a P-type semiconductor. In N-type semiconductor, the electrons are majority, and P-type semiconductors, holes are majorities. So in P-type semiconductors, some free electrons are available. Formation of PN junction. As we know that the normal meaning of junction means when we are adding two things, when we are comparing two things, the junction will be formed. In the similar way, we are adding N-type semiconductor and P-type semiconductor together, the PN junction is going to form. It is also defined as the boundary between the P-type and N-type semiconductor. The formation of PN junction. So after forming this PN junction, it is going to be used as many applications like transistors, solar cells, light emitting diodes, integrated circuits. And this diode is going to be used as inside the computers, power supplies, television, radios. But before the invention of semiconductor diode, there will be an vacuum tubes, which is large in size, takes more power, costly and noisy. So this problem was solved with the invention of semiconductor diode. You can look at the picture of vacuum tubes and PN junction diode. In charge carriers crossing the junction. In PN junction, if we didn't apply any external voltage, it is called as zero bias PN junction. So zero bias PN junction is also called as unbiased PN junction. So let us consider zero bias PN junction as shown below in the behavior. In N-type semiconductor, the large number of electrons are available, and P-type semiconductors, large number of holes are available. In N-type semiconductor, the many number of electrons are available. According to the Coulomb's law, in N-type semiconductor, concentration of electrons is very high, while the concentration of electrons at P semiconductor is very low. Due to this high concentration of electrons at N side, they get repelled from each other. So the electrons are trying to move to the P-type semiconductor. Similarly, in P-type semiconductor, the holes are having a very high concentration. So according to Coulomb's law, there is an electrostatic force of attraction between the opposite charges. So electrons are moving from N-type to P-type, and the holes are moving from P-type to N-type. So it is going to be create a positive ion at the N-type and the negative ion at the P-type. This is the way of the formation of ion. Thus, when the electrons are moving from N-type to P-type, more number of electrons are going to store at P-type region. So it is going to create a negative ion. And the holes are moving from P-type to N-type. It is going to create the more number of holes at the N-type. So it is going to create a positive ion. The next thing is charge atom. If the atom has unequal number of electrons and protons, then the atom is said to be charged. There are two ways of charging is there. One is positive or negative. The atom has more number of electrons than the protons. It's said to be negatively charged. And the atom which has more number of protons than the electrons is said to be a positively charged. Yes, as we discussed right now, formation of positive ion and negative ion. The next thing is positive and negative barrier voltage at the PN junction. Already we know that the creation of positive ion and negative ion. Now barrier voltage means it is going to stop something. So the positive ion and negative ions are going to work as in a barrier voltage. So the positive ion is going to as in a positive barrier voltage. So which means that it won't allow any holes from p-type region to n-type region. And negative barrier voltage, that is in p-type semiconductor, negative ions are going to work as a negative barrier voltage, which means that it won't allow any further flow of electrons from n-type region to p-type region. So here you can look at the picture of a positive barrier and negative barrier. So in n-type semiconductor, the positive ions are created. So this positive ion is going to work as a positive barrier voltage. And in p-type semiconductor, negative ions are created. This negative ion is going to work as a negative barrier voltage. That means both the ions are, it won't allow any further movement of electrons and holes from the sides. The next thing is depletion region. Generally, depletion refers to reduction or decrease in quantity of circuit. So here region means already we know that the positive ion and negative ions are created in the p-n junction. So in this region, it won't allow any further movement of electrons and holes through the junction. So this region is called as depletion region. Here you can see the definition. The region near the junction where flow of charge carriers are decreased over a given time and finally results in empty charge carriers or full of immobile charge carriers is called depletion region. So we can differentiate this depletion region while adding two types of impurities. That is, the width of the depletion region is defined by the impurities only. See the differentiation here. When we are adding heavily doped impurities, the depletion region width is very, very low. When we are adding lightly doped semiconductor, lightly doped impurities, the region of the depletion region is very, very high. Yes, that's all about today's class. Remaining we'll discuss in the next class. Thank you.